Let's take a look at the definite integral of a somewhat more complicated function, in this case a second degree or quadratic polynomial. We already know that we can take the antiderivative one piece at a time. So this is going to be the same thing as 1/3 x to the third minus x squared plus 3x evaluated from 1 to 4. Again, we don't have to worry about that constant of integration for definite integrals. It is not going to affect the final answer. If it helps you to put it in there, to remember to use it also when you're doing indefinite integrals, by all means please do, but it's not required. This is going to give us 1/3 times 4 to the third minus 4 squared plus 3 times 4. And I'm going to put all of that in brackets. And then we're going to subtract 1/3 times 1 cubed minus 1 squared plus 3 times 1. So we evaluated the upper limit, we evaluate the lower limit, and we take the difference. So here we're going to get 64 thirds minus 16, which is the same thing as 48 thirds, plus 12, which is the same thing as 36 thirds, minus, we're going to have 1/3 minus 1, which we can think of as 3 thirds, plus 3, which we can think of as 9 thirds. So we're trying to convert everything to thirds here, since I'm seeing that come up as a denominator. So 64 minus 48 and plus 36. I'm going to trust my calculator to do that for me here. And let's see what I get. I get 64 minus 48 plus 36. I get 52 thirds. And we're going to subtract. Let's see, we're going to have 1/3 and 9 thirds is 10 thirds minus 3 thirds is 7 thirds. 52 minus 7 is 45 thirds, or it looks like we end up with just 15 for that one. Now, as a way to check yourself, you can use the calculator. So let's pop over and see if we can graph x squared minus 2x plus 3 on the appropriate interval. So let's go to y equals here, and let's type in x squared minus 2x plus 3. Notice that I'm graphing the original integrand. We want the area under the integrand. When I use a graphing calculator and try to look at the area, we don't want to look at the antiderivative. That's just a tool we use to find the number. But the actual picture and everything comes from the integrand itself. That's what we're trying to find the area relative to. So I'm going to set that up. I'm going to go into the window, and I'm going to set x min to 1. I'm going to set x max to 4. And then I'm going to zoom fit and let the calculator choose my x and y values. So I'll choose zoom, option 0, and I'll let it graph. This is what I get. I notice that I don't seem to have the x-axis down here, so I'm going to click on window and take a look at my y values. And I see that this is going from a y min of 2 to a y max of 11. I'm going to change that y min to 0, just because I'd like to be able to see the x-axis when I graph. Now I have a better picture of what the area looks like. So on my left bound I have x is equal to 1. On my right bound I have x is equal to 4, so I want all the area in between there. And this is a positive function, a non-negative function, so we really do get area in between the x-axis and the function itself. If we press the second key and the trace key and go into the calc menu, option 7 allows us to look at the numerical value of an integral. It asks for a lower limit, which is 1. It asks for an upper limit, which is 4. And then it will color in the area, and it will give us a value back. If you ever try this and you get some errors with your upper or lower limits, take the window and stretch it out just a little bit. Sometimes you might need to take the window from like 0.5 to 4.5 so that the x values are properly on the screen, which is something that the calculator wants, and it's hard to see visually what's going on, whether they are or not. But you'll see we get exactly the same value we just calculated. We get the value of 15. I do want to be clear in showing you this. This does not replace showing your work, finding the antiderivative, doing the substitution, and finding the area on paper. This is simply meant as a way to check things. please do not use this as the way to solve problems in WebAssign or on your tests. Make sure you can do all of the work on paper. Make sure that this is nothing more than a way to check your work and see if what you're doing makes sense.